All right, good morning from snowy New Mexico. We're having our first big winter storm of the season, so I'm hopeful that the power will stay on while we're having our little chat this morning. Um, I'm Heather Kotula, President and CEO of Access Innovations, and I'm proud to introduce Margie Lava, Founder and Chief Science Officer of Access Innovations, who's going to talk to us about understanding how search works. Over to you, Margie.
Thank you, Heather. I just want to make sure everybody knows that I'm not going to cover in 1 hour what you would cover in a semester class at the university, but I do want to give the basics of search for people, and particularly those who are trying to implement something in their workplace, because it's the basics behind search that affect the implementations that I want to talk about. And so I thought I'd do a quick little who am I? I've written 5 books on search and database creation and taxonomies. I have 2 patents with 21 claims granted, and I've been active in search actually for over 50 years, and have built over 600 thesauri, and our company has done more than 2,000 engagements. So we've gotten into the implementation level pretty heavily. I've also done a lot of standards work, particularly standards that have to do with metadata and database creation, including the Dublin Core, the DOI syntax, the credit, giving an idea of what role people play when they get to be an author on an article. The thesauri standards, including the Z39.19 and the international one, the 25964. And then there are a couple of standards that we've written for standards, like the standard specific ontology, which has just passed. It's a new ISO standard. I'm the current convener of the ISO 25964, which is the international standard for controlled vocabularies, and it's a really fun piece of work. I have a great committee, and of course, I'm founder, chairman, and chief scientist of Access Innovations. And we have a lot of clients, and you see from this quick shot, they come from a lot of different areas and types, but what they have in common is a lot of text. And so it's a lot of text that we deal with in getting these search systems implemented. What I want to cover in the next 50 minutes is the parts of search, what makes them work inside, and then some about why search fails. Then I want to talk about metadata, particularly subject metadata as the thesaurus effect, and then search enhancements. I want to give a little attention to filter bubbles and a passing reference to large language models as search, particularly since today is the official launch of ChatGPT's search system. So people talk about search, but then you don't know what they mean. You don't know if they mean an engine or software or a large language model, and they're different. So a search engine is something like Google or Bing, and they crawl the web, they index pages, and then they rank the answers, some fairly significant ranking and weighting to get answers to a query. Search software is something more like Lucene, also known as Solr, with better documentation, Indecta, Dialog, or Ovid, or one of those. And it usually uses fielded database information that comes from a database and has been tagged to indicate the different structures within the data. And behind that is created an inverted index, and that inverted index we're going to spend a little time on. And it answers using categories or text strings to give people a place to go, an article to find. Large language models, of which there are an increasing array, like OpenAI or Bard or Cloud or Gemini or DALL-E or Midjourney or any of those, gather data from every place it can scrape it off the web, and they create vectors and co-occurrence locations also known as neural nets and all kinds of statistical algorithms to find data. They need a lot of data and a lot of power, which is why one of them just bought the 3 Mile Island nuclear plant. They add a conversational GUI at the front end so that they can answer the question in a conversation and don't historically give where that information came from that they used to answer the question. Today, we're going to concentrate on search software, and we might give a passing mention to some LLMs and other things. So search software is a, now somebody has raised a hand. Do I need to view that? I'm not sure. Heather, I'll let you handle those.
Yeah, let me handle those.
So when you're searching, all those different kinds of search softwares, not to be confused with search engines or LLMs, use relevance rankings and might use a relational database or a graph database or RDF or triple stores behind the scenes, but most of them stick with a more basic inverted index. Sometimes the search will depend on relevance and co-occurrence or on weighted fields like the taxonomy tags, but it's all applied to the individual information objects, whether they're a video or an article or a tech report or whatever. And then I do want to give some attention to tagging using metadata, particularly taxonomies, because it really increases the consistency and accuracy of search. So the data is mostly text, or it's converted to text. If you're indexing an audio, you convert the, or a video, you convert the audio string to text and then index against that. And people talk about unstructured text, and that's where everything is loaded in one big continuous text stream as a blob. Structured data, also known as fielded data, usually has metadata like tagging who the author is and tagging the publication or the publisher and the date of publication and place of publication and all those kinds of things, those library card entries, but also more general metadata. And they may be in XML, they might have tags in left-tagged ASCII, they might be Excel spreadsheets, they can be structured in a lot of different ways. And then the subject metadata is adding from a controlled vocabulary, but also adding author keywords, which helps with the finding of information. The reason for doing the taxonomy tagging and adding that to the search parameters is to get higher accuracy and consistency. So these are some samples of search software. There's a lot of them. I'm going to use primarily Lucene today as an example, although at bottom or most basic levels, they all operate much the same. Search engines are things like Google or Bing or Apple, and there's some aggregators and influencers who use those kinds of systems as well. But it does require a lot of data to make them work. So the parts of search include the inverted index, the search algorithms, and then on top of that, you put some kind of a presentation layer, the GUI, the user interface, which will include a search box, the little box we're all familiar with. Auto-completion is frequently there. Related concepts might be presented, and then there can be advanced search options depending on the system. So I've mentioned inverted index a number of times already, so let's look at what an inverted index is. If we pretend everything in this box here, the blue box, is a document, and it's very, very simple, but notice the word thesaurus is mentioned 3 times. Functions is only listed once, tool is listed once, and so on. So you could say this was the chapters of a book or something, and In doing that, you'd have a small document to work with. Well, the system will take this information and create it as a alphabetic list. The high ASCII characters float to the top, then the numbers, and then alphabetically all of the information. So it makes a great big linear index for people to search. But that doesn't necessarily give us the level of specificity that we're looking for in search. And so what people add in addition is location. They might say this is in line 7 of paragraph 2 as a heading. And the thesaurus over here has been a heading and a subheading in paragraphs 1, line 3, line 7, line 8. So we know the location, and we can add all kinds of other things to this, like the any number of identifiers, like the ISBN or the DOI or something else. We might also add stop words, things that would clutter up the index that we don't want to waste a lot of space adding. And most systems will give you control of those stop words, because if it's a business database, you might want to have access to a word like management by objectives, but otherwise by would probably be a stop word. So we have this stuff sorted with the location added and all kinds of additional information. And this then forms the complex inverted file index. So when people are searching those inverted files, they have the inverted file index, which is the searchable index, and then they might have a hierarchical display of information that might be from a thesaurus or taxonomy or some other source. And then they combine the terms using Boolean commands. And if something is not in the inverted index, it cannot be searchable. So it's real important to pay attention to what goes in to your inverted index, because people don't put everything in the inverted index. They only put part of their information in the inverted index. And then you have to search the rest, either string commands or some other methodology. So let's take the case example of NISM and its Media Sleuth website. So their need was to get more items viewed, more items found, so that they could get more orders for videos. They wanted something that was easy to implement and decided on taxonomy search so that users could find information faster. And they wanted to be able to save those searches as well. And they wanted to be able to support contextual Google ads so that in their system, they could help pay for it by supplying ads. And some people do their own ads. It's an association, for example, they might put their ads in there for upcoming events or for other related papers and so on. So what happened is the web stats came up and were increasing, and they got a lot more orders. That was launched in Apache Solr. So Lucene is the name of the Apache software, and then Solr is a wrapper that goes around it that gives a whole lot of additional helpful ways to implement the engine more quickly, and a lot more documentation that's easy to read. It is open source, and it's web friendly, and it is probably the most widely deployed search software at the moment, and it can be used by non-programmers. However, a lot of programmers don't know a lot of the things that you can do with Lucene. So the data usually comes from some kind of a data store, an SQL or XML intranet system or a CRM or something like that. That data is often fielded when it's loaded into those data. So you do have somewhat structured data that you've loaded into the Solr, and part of the Solr offering is that inverted file. When somebody does a search, they go in through the user interface with a query to the inverted file, and it goes back to the user interface and gives the answer to the user who's been querying the system. This is a little bit more complex version of it. You see over here that there's a database. You see over here that there's a leucine index. And so there's a repository with the fielded data that Lucene is going to search. They get there through the presentation layer. That's where the query comes in from the user. And we can add all kinds of things on the presentation layer. But the query is going to hit the search, look for snippets from the repository, gather that information, and then eventually return it to the user query. And this is what a front end might look like. So you might have auto completion, which is in this case a permuted index from the alphabetic list of the preferred and non-preferred terms in a thesaurus. You might have a way to get them to narrower terms or other semantic relationships like related terms, invoking perhaps part of the ontology relationships, and allow people to navigate on the full taxonomy tree. And in this case, the tree gives you the number of hits behind each term, so you know how many or how few pieces of information are there. And then clicking on one of those can take you directly to a product page, which gets you to a shopping cart or however you want to vend it to get to an e-commerce site. So the classic database system is then going to have all that stuff that's in green on the right, all kinds of whatever the sources are, put into some kind of a document storage system. And then that information is moved to maybe an SQL database to support e-commerce, a journal platform for distribution of the journal information, a content repository, which may hold the article of record, for example, and then the search system. And some of these will have, these repositories will have a search system underneath them, or it can be separate if you want it to support, for example, the website. Into that document storage and creation system, once the documents are loaded, you might want to add the metadata to it. And of course, then access the information through the website. So this is just a sample backend database where the data is being fielded. And perhaps you'll put a lot more description into the information along with product coding, product type, system requirements, language information, and so on. This one being a video database includes the length in minutes and seconds. So before adding data to the Lucene index, in this case, we submitted it to the Data Harmony automatic indexer to extract taxonomy terms and add them to the information. So it goes to get suggested terms, passes through the indexer, and then adds the suggested terms to the document itself. So the data challenge that people face is the complexity of the media that they have. And everybody knows that their data is more complex and difficult than anybody else's. Maybe, maybe not, depends on how much of that kind of data you've seen in the past. Educational media, which is what NISM had its own challenges. For example, it changes hands regularly. So if you were going to list who owned the content, you had to constantly keep track of who owned that intellectual property. The formats changed 1 year, over 25% of the data changed format. So it might be in film or CD or streaming. And as new medias come available, you need to offer that. And the prices might change for different media. There also might be linked media, which would make for an interesting series, or for other things that might be of similar interest to people. There's also a lot of different media styles and a lot of different search styles. Different people with different needs are going to search differently. So we reloaded the entire database monthly in this case. I've mentioned thesaurus several times, and I know most of you know what that is, but it has a number of pieces to it. One is a hierarchical outline by subject category, and that's a basis for browsing. It is a outline of knowledge or a framework for college content organization. And the reason people do it is an increased recall and precision for high accuracy. In the case of NISM, its thesaurus was about 5,000 terms. And this is a picture of it with the taxonomy view as well as the full record view. And then for automatic indexing, you can see these blue blobs show you where something was triggered to come up with a list of suggested terms for the information, and that's automatically triggered, or it can be used in an assisted mode. So, okay, search isn't that hard, at least so far. So how come it fails? Most large organizations have at least five different search software packages on the shelf, and they're all disappointing. They didn't work, so they went out to get a new one because they gave inconsistent results and an unclear path to results. They didn't have a single, clear, consistent vocabulary, and generally they weren't tied to any kind of data governance. So let's look at this metadata stuff a little bit. If you take an example of non-intuitive synonyms, things that you couldn't have guessed. In the case of the American Society for Clinical Oncology, they deal with cancer. And they have a word called invasive breast cancer, metastatic breast cancer, and stage 4 breast cancer. All of them mean exactly the same thing. But if you look at them in the database and you only search for them one at a time, you get 520 results for invasive breast cancer, 1803 for metastatic breast cancer, and 73 for stage 4 breast cancer. Well, I would want my medical term to see all the results, and without that, without a synonymy, meaning all these things are equal to each other, they can't get them all at once. So they built a thesaurus about 7,000 terms, and this is a quick shot of it. And what they did was in Lucene gather all the synonyms together and made Lucene use taxonomy term priority in search. So when people searched, they could search for any of those 3 terms and get all of the results, no matter what they called it. And that meant it was a lot easier for people. We have other databases that have a lot of synonyms. For example, the Medicinal Plant Names Service out of Kew Gardens. The Royal Botanical Gardens at Kew has an average of 16.7 synonyms per plant name. And the Human Genome Project has an average of 19 synonyms per gene name. Well, you can't do your research if you don't get them all. And so it's really important to get them all. Okay, so I'm going to not beat that drum anymore. I want to talk about how accuracy is measured. Okay. People talk about precision and recall. They also talk about relevance, and I'll get to that in a minute. But if you want precision, then you want to look at the correct retrieval over the total number of items that were in the database. That means the hits, someone that a human would choose, but a computer did not. And that's the stuff you want. But if you take the hits and all the other stuff that's noise or stuff that a human would not have said was correct, you get the precision ratio. If you want to know about recall, you get all of the hits, plus all the stuff that was missed, all the stuff that the computer should have gone over but didn't. And then you look at that and you get the total level of recall. And if you want to know the total level of effort, you get the number of hits over hits, misses, and noise. And that's how you calculate precision and recall in a database. So I just told you this, the hit, the miss, and the noise. You could use more sophisticated names, but those seem to hold pretty well. But what about other ways. When Google came on, we heard a lot about relevance, and precision and recall kind of went to the wayside. But relevance is subjective. It depends on a person saying how akin it is to a user's request. And there are lots of things like personalization that are used to make it more relevant to any particular person. I'll talk about relevance in personalization at the end of this talk. So it reflects the level of conceptual terms versus factual terms to get what the topical match between the document is and how well people think that actually matched their query. So one of the things that we do in a thesaurus in that inverted index is not just breaking on every space, which is known as word parsing. Instead, we might break the words conceptually. So if we took coffee cup, for example, do we want all the instances of coffee and all the instances of cup? Or do we just want them when they're together? So you could put them in quote marks, and your system may or may not search them as a term together. But you could also ask it to do phrase indexing, which would give you the right to break the term apart at its required spot. That is, you bind the phrase and you look at it only when they are together and in the order that you presented them. And you get a lot tighter retrieval if you do that. You can do that on Google too, but most people don't. They just put in the word and assume that they will search that way. But most search engines default to an or. So you get coffee or cup instead of coffee and cup. But I want coffee and cup in that order. So I want it as a phrase. So what about some other parts of search implementation? Well, we have stemming, where you cut off what's known as the gerund endings or depluralization, the S and the ing and the ed and other things that make a term in English work different ways, but we really just want the word root, and that's known as stemming or lemmatization. We also might want to truncate either on the left-hand side or the right-hand side. Right-hand truncation is easy, left-hand truncation is not. So right-hand truncation is often implemented, but left-hand truncation would mean that you have to go and build an inverted file for every option that could precede it on the left. Very expensive computationally. You might also put in wildcards, particularly if you're searching variations in a single language, like organization with an S or a Z, depending on if you're English or American. And then also variant spellings that you might want to capture, which are all absolutely correct, but different. And then there's the problem of hyphens. If you put hyphens into the data, you lose everything to the the right-hand side of the word when you search. So you can stem for a hyphenated word, but you don't get left-hand truncation, which means that you miss an awful lot of information if you insert hyphens. So if you have to put in hyphens, I recommend that you put in a space hyphen space. So this is an example of what stemming will do for you. This search for horse in Google returned over 2.7 million hits, but horses gave you 1.8 million, and horse truncated gave you 2.3. So that would be with the E. If I'd done horse to include horsing and stemmed it a little earlier, I would have gotten a different number. So you can see that you get a lot of different numbers depending on how you do the searching for stemming. So I've talked about searching taxonomy terms first. If you have tagged your content with some kind of a controlled vocabulary, you want to search that preferred form, and then you get all the synonyms added equally so that they're all searched together. And you can do that in a field that you want to specify as well, you could search the body or the abstract or the title. And if you got no results on the controlled terms, you could go ahead and shift over to full text and search it that way. So the search software is bound by a set of algorithms that have a front end UI and back index and indexing and a lot of other features. The search engines are aggregators that offer a lot of data in exchange for ad viewings, and sometimes they're available for in-house use. A lot of people have tried the Google search appliance. It didn't work very well for them because they didn't have enough data. I mean, you need millions of objects, and most people have thousands or 100,000s of objects to really make the Google search appliance or any of those kinds of engines work well. So whether people use Bayesian or Boolean search, Bayesian being vector searching or statistical searching, and Boolean being the and, or, and not that you've heard a lot about, I give a full webinar on that, so I won't talk about that today very much. But it does make a big difference in the emphasis of which way you're going to search your data. So when you choose a search software, you need to choose which direction you want to go in using that, using one as the priority or the other. Most search engines actually have both, but they give either Boolean or Bayesian priority in how they design their system. Search engine optimization is a popular thing, and you can use the same kinds of algorithms with search software, either for making your page top 10 on Google and getting it picked up by other systems, but it's a way of including information in your information that you put up on the web by adding certain information in your HTML header. If you get lots of different things about that piece of content posted within a 4-hour window, perhaps you might get higher postings. You just have lots of ways to move things up the list. And the same can happen with weighting within your own software. Wow, I'm whizzing right through this, I think. In social media, on the search engines, we use co-occurrence to see what articles occur together, so that we can get an idea of what might be interesting, and then rank them to see what others clicked on and who liked that. If they liked it, probably you're going to like it. And if you click historically on one thing or another fairly frequently, because that was what piqued your interest, after a while, the system is going to give you the things you like, and you won't see the things you don't click on. It'll save you time, and it provides you a lot more relevance to your queries generally. But it does create something called a filter bubble. So Eli Parcier, the guy that ran the Obama social media campaign, gave a really interesting TED Talk, which I recommend you try to look up. He talked about, at that time, he was looking at how the crisis in Egypt was affecting people, and he looked at his system, and he looked at his friends, and I could come back and play this, but I'll just make sure we have time before I do that. And what he found was, I think I can move forward, that he and his friend, one was looking for tours in general, the other was looking at politics, and they found that they got radically different results from the same search query in the same search software, because historically they looked for different information. It was the way personalization worked for them. And so if you didn't see things that other people have seen, you're only seeing one part of the study, it's because it's tailored to you. It's personalized. It gives you everything presented to you because they're like-minded articles, and social media uses that a lot. It is Facebook or Google or any of them will present things similar to what you've looked for before. So if in the election, for example, you said, I can't believe everybody voted X or Y, it's because a lot of people were seeing something else when they did a search or got their news. They were looking at different results because that's what they were comfortable with and that's what they clicked on. So it can cause a really large digital divide on all sorts of issues. And it's part of the reasons there's so much controversy these days because people aren't reading the same stuff. There's so much to read, you have to select it somehow. And one way to do that is through personalization. Makes it kind of hard. Okay, so that was kind of a blitzkrieg. I'm not sure what time. They don't have a clock. I'm doing okay. We looked at the inverted index and we looked at why search fails. We looked at the thesaurus effect and we looked at some options for search enhancements. And we've looked at filter bubbles. And that's pretty much my slide deck, except that you might say, well, what about AI? What about large language models and all that stuff? Knowledge graphs and knowledge maps and ontologies and RDF and Sparkle and so forth, which is represented by things like this. I mean, those kinds of diagrams and how that information gets together and is shared and presented. And I am going to talk about that, but in the next webinar. And you might say, well, we were planning our new install. We're working on a new problem. We're thinking about replacing our search software because it doesn't work. No kidding. So what I would recommend to you is maybe you consider before you do that great big search and spend money on and concentrate on servers and telecommunications and buying new software or getting a new CRM, concentrate on cleaning up your content, enriching it, looking for problems with it, and then choose the rest of the platform. I think it'll work better. And besides that, there's new stuff coming out every single day. And which way the industry is going to go next is pretty hard to tell. Most of the really large language models are not appropriate for a company that has up to 200,000 pieces of content that they want to put into a new system. What it does work with is millions of pieces of data. However, I think that's the new frontier. I think that they are working really hard, all of these companies, to build what they call focused language models, ways that people can get their information together and put into a new conversational interface, looking at large bits of content so that people can get their answers. So I would be ready to take questions now, I think, if you have some, and otherwise I'll go back and play that Eli Parcier.
We have a couple questions.
Back to you, Heather. What do we have for questions?
Yeah. Dawn says, Marjorie, great presentation. Is it recorded, as I missed a few moments? And I can answer that one. Yes, we are recording, and we will put both the recording and the slides on our website. It might take us until next week, and I will send out an email with those links when they're available. He has another question, which is, what about other search engines? For example, Yahoo.
So Yahoo is another search engine aggregation and runs on their own software. But behind the scenes, it's very much like the Lucene system that I covered. So in that it's a huge inverted file system. It's not a Google system. Google is rankings and weightings.
Yeah, I think you can go ahead and play the video if you'd like. We still have just under 20 minutes left, and you can play that while other people are entering questions.
Okay. Not exactly sure how that'll work, but let's give it a try.
Let's give it a try.
Can you hear it?
No, we're seeing your slide on personalization.
Okay.
Do you need to share a different window?
Here are different screens, so let me let me do that. Where is it? Here it is.
The wonders of technology.
Now, let me reshare that. One.
You may need to.
You seeing it?
We're seeing it. I think the sound is turned off on it. Do you hover there at the bottom of the window? Yeah.
Right now, and people dying.
That's good.
And I want to talk about what a web based on that idea of relevance might look like. So when I was growing up in a really rural area in Maine, the internet meant something very different to me. It meant a connection to the world. It meant something that would connect us all together. And I was sure that it was going to be great for democracy and for our society. But there's this kind of shift in how information is flowing online, and it's invisible. And if we don't pay attention to it, it could be a real problem. So I first noticed this in a place I spend a lot of time, my Facebook page. I'm progressive politically, big surprise, but I've always, gone out of my way to meet conservatives. I like hearing what they're thinking about. I like seeing what they link to. I like learning a thing or two. And so I was kind of surprised when I noticed one day that the conservatives had disappeared from my Facebook feed. And what it turned out was going on was that Facebook was looking at which links I clicked on. And it was noticing that actually I was clicking more on my liberal friends' links than on my conservative friends' links. And without consulting me about it, it had edited them out. They disappeared. So Facebook isn't the only place that's doing this kind of invisible algorithmic editing of the web. Google's doing it too. If I search for something and you search for something, even right now at the very same time, we may get very different search results. Even if you're logged out, one engineer told me, there are 57 signals that Google looks at. Everything from what kind of computer you're on, to what kind of browser you're using, to where you're located, that it uses to personally tailor your query results. Think about it for a second. There is no standard Google anymore. And the funny thing about this is that it's hard to see. You can't see how different your search results are from anyone else's. But a couple of weeks ago, I asked a bunch of friends to Google Egypt and to send me screenshots of what they got. So here's my friend Scott's screenshot. And here's my friend Daniel's screenshot. When you put them side by side, you don't even have to read the links to see how different these two pages are. But when you do read the links, it's really quite remarkable. Daniel didn't get anything about the protests in Egypt at all in his first page of Google results. Scott's results were full of them. And this was the big story of the day at that time. That's how different these results are becoming. So it's not just Google and Facebook either. This is something that's sweeping the web. There are a whole host of companies that are doing this kind of personalization. Yahoo News, the biggest news site on the internet, is now personalized. Different people get different things. Huffington Post, Washington Post, New York Times, all flirting with personalization in various ways. And where this moves us very quickly toward a world in which the internet is showing us what it thinks we want to see, but not necessarily what we need to see. As Eric Schmidt said, it'll be very hard for people to watch or consume something that has not, in some sense, been tailored for them. So I do think this is a problem. And I think if you take all of these filters together, if you take all of these algorithms, you get what I call a filter bubble. And your filter bubble is kind of your own personal, unique universe of information that you live in online. And what's in your filter bubble depends on who you are, and it depends on what you do. But the thing is that you don't decide what gets in. And more importantly, you don't actually see what gets edited out. So one of the problems with the filter bubble was discovered by some researchers at Netflix. And they were looking at the Netflix queues and they noticed something kind of funny that a lot of us probably have noticed, which is there's some movies that just sort of zip right up and out to our houses. They enter the queue, they just zip right out. So Iron Man zips right out, right? And Waiting for Superman can wait for a really long time. What they discovered was that in our Netflix queues, there's kind of this epic struggle going on between our future aspirational selves and our more impulsive present selves. We all want to be someone who has watched Rashomon. But right now, we want to watch Ace Ventura for the 4th time. So the best editing gives us a bit of both. It gives us a little bit of Justin Bieber and a little bit of Afghanistan. It gives us some information vegetables. It gives us some information dessert. And the challenge with these kind of algorithmic filters, these personalized filters, is that because they're mainly looking at what you click on first, it can throw off that balance. And instead of a balanced information diet, you can end up surrounded by information junk food. So what this suggests is actually that we may have the story about the internet wrong. In a broadcast society, this is how the founding mythology goes, right? In a broadcast society, there were these gatekeepers, the editors, and they controlled the flows of information. And along came the internet, and it swept them out of the way, and it allowed all of us to connect together, and it was awesome. But that's not actually what's happening right now. What we're seeing is more of a passing of the torch from human gatekeepers to algorithmic ones. And the thing is that the algorithms don't yet have the kind of embedded ethics that the editors did. So if algorithms are going to curate the world for us, if they're going to decide what we get to see and what we don't get to see, then we need to make sure that they're not just keyed to relevance. We need to make sure that they also show us things that are uncomfortable or challenging or important. This is what TED does, right? Other points of view. And the thing is, we've actually kind of been here before as a society. In 1915, it's not like newspapers were sweating a lot about their civic responsibilities. Then people kind of noticed that they were doing something really important. That in fact, you couldn't have a functioning democracy if citizens didn't get a good flow of information. That the newspapers were critical because they were acting as the filter, and that journalistic ethics developed. It wasn't perfect, but it got us through the last century. And so now we're kind of back in 1915 on the web. And we need the new gatekeepers to encode that kind of responsibility into the code that they're writing. I know there are a lot of people here from Facebook and from Google, Larry and Sergey, who, people who have helped build the web as it is, and I'm grateful for that. But we really need you to make sure that these algorithms have encoded in them a sense of the public life, a sense of civic responsibility. We need you to make sure that they're transparent enough that we can see what the rules are that determine what gets through our filters. And we need you to give us some control so that we can decide what gets through and what doesn't. Because I think we really need the internet to be that thing that we all dreamed of it being. We need it to connect us all together. We need it to introduce us to new ideas and new people and different perspectives. And it's not going to do that if it leaves us all isolated in a web of one. Thank you.
Very interesting. So we have a related question from Jay, which is, how do you break out of a filter bubble?
So you can do a couple of different things. One thing you can do is click on stuff that makes you uncomfortable and make sure that you continue your search patterns in a more general way. I have a whole lot of computers. And so what I do is and because I'm independent, I'm not from one party or another, I search my conservative news on one computer and I search my liberal news on another computer. And that way it is tailored to me. Not everybody has that option, but it is interesting that I get really different results on those different computers, but I have to be careful. Okay. And then
we have another question from Jay. Could you talk about prompt engineering versus the reference interview?
So prompt engineering is a term that's come up with the advent of these large language models. And it's really the new reference interview. It's a matter of learning how to code your query so that or write your query so that it does everything you want. The difference is that you also need to tell it what style you want it in, and how much you're expecting, and it won't give you references to the information that it provides. It's just going to provide you the answer as it sees it from the aggregate of everything that it's scraped. And it's interesting that and there's been studies on this already, that the information that is crawlable on the net tends to be more liberal than conservative. People who are conservative don't want you touching their information. People who are liberal are happy to give it to everybody. And so there's a initial bias in the information. And I know that the systems are trying to balance it, but it's hard. Given the preponderance of what's written and what's not. So crafting the prompt is a bit of a science, but if you were good at the reference interview, you'd probably take to it pretty quickly.
Another question, do you care to comment on multilingual searching? Is it best to rely on Unicode or indexing to do the work, parentheses crosswalks, or better to search within the foreign language, presuming that the corpus is multilingual?
Well, it depends on what your software is going to support, but if you can get if you can get 16 instead of UTF-8, then all the characters in the many languages can all be added to your inverted index and you can search them all together. However, most people use UTF-8, which is one of the Unicodes, and I think almost nobody uses 32. So if you can do it, it's nice to search it initially, but and you can search in the native tongue, because an awful lot of the concepts do not translate directly. The people in the European Union, for example, with the Unicode, with the Eurovoc vocabulary, which is last time I looked at it, it was 27 languages and 4 character sets. But the challenge was that things are not a cognate. You can't translate directly the terms. The Eurovoc and the European vocabulary was originally written in French, And France uses Napoleonic law. And Napoleonic law says you're guilty until proven innocent. And common law, which is what's used in the UK and the US, says that you're innocent until proven guilty. So you cannot assume that even the most basic search construct using just terms means the same thing. So there's a whole lot of benefit to have putting contextual understanding around a query.
And this next question follows right on that. Can you spend a few minutes talking about semantic search concepts, especially around contextual understanding a query? For example, understand query intent like Apple, where the system needs to determine whether to show results related to Apple nutrition versus Apple stock.
Well, so we just saw a video on tailoring. So if you looked for a lot of stuff about food, it would automatically give you more information on nutrition versus stock, unless you meant stock, like in stock soup for apples, although I've never really, well, I suppose cider is apple stock in that context. But if you were looking for the financial stocks, you'd have to disambiguate the term in some way by saying one was fiscal and the other was food.
Okay. Same person is interested in hearing more about ways for measuring search quality. You talked about accuracy, precision, and recall. Can be done by using external judges to provide labels, but this does not scale for large systems.
True. That's why large systems use relevance. So instead of depending on precision and recall, large systems are looking harder toward relevance rankings based on statistical vectors and the smart logic of Jerry Salton, because they want to balance it programmatically. And the only way to do that programmatically is to assume that co-occurrence would indicate that it would be more relevant. If it happens a lot in those sequences, then that's likely to be the most relevant answer.
We have one more question in 2 minutes. Is it still desirable for a system to show users the structured, controlled vocabulary to help them choose search terms, or do we just expect the system to use that behind the scenes in black box mode?
Well, a year ago, it would have been clearly that we want to let the black box do it. But lately, even the large language models are finding that they want to use the controlled vocabularies to show them and to guide not only the system, but the user as well. So that is changing as we speak. And historically, it would have been the less you need to go with a controlled vocabulary, the better. But that pendulum is swinging back, and it actually surprises me that large language models have caused an intense demand for controlled vocabularies lately, whereas I would have guessed a year ago that they were going to put us out of business.
Well, I certainly hope that doesn't happen. I don't see any more questions, so thank you very much, Margie, for joining us today. Thanks to everybody who attended. And watch for an email with those links to the recording and slides. And of course, if you have additional questions, you can always reach out via email. Thank you.